that are being made with robots are still pavilion scale, and things that how we actually scale this. So we were very inspired by this problem, and then we tried to create a structure that could be customized, but then also like a prefabricated component that we could actually use in a building. So there are cases, of course, of this being applied, and this is what, although we were testing a methodology and trying to outline all the problems and all our goals, the main thing was trying to came with something that will be a repeatable component in a building.
So that you can easily imagine this mushroom column being doubled in a building. Of course, there are a lot of other problems with scalability,
yeah,
which is the size of the robot and the materials. Maybe try to look into composites that can have the similar properties to the foam. So we went there, but it's too preliminary to went.
Yes. So we find.
Yes, please.
It's a really great, fantastic project. One question about the component. Is the component looks like it's curved or is it flat?
So it's double curved.
The component is double curved. Yes. So how do you get the components to double curve?
Well,
in terms of fabrication?
Yeah.
Well, it was a very complex, we didn't talk about that because actually we really envisioned to simplify what we need.
Yep.
But the process was actually each component is made of 3 different pieces that are flip milled in a CNC machine.
So you CNC and then you flip it?
Yes.
Okay.
So, but each
Okay.
component,
Okay.
as there is a gap in between, each component has 3 parts, and they are then assembled, and then because it's impossible to make this piece as
And
inside.
just a quick comment is, I really appreciate the connection to architecture history, like to NERVI, and then you try to resync like the construction process, like saving like the scaffolding, already like thinking about like sustainability. And I think there are many ways of like, I mean, how that could inform like a next step. Because one way could be that you just complexify the form. Because I mean, you at the moment here, I think you have like a repetition of like the same thing. But if you have like, if you're using CNC to fabricate the module, then it's very easy to basically just say, like, now what if every piece is completely different?
We believe that
you don't need repetition.
Yes.
This diagrid strategy can, I mean, again, we didn't want to present it because it's very preliminary thoughts, but yeah, we definitely thought that we don't have to have this totally symmetric, equivalent pieces.
Perform in different ways, not necessarily perform symmetrically in a structure.
Even the thickness can change.
Yeah, as long as you use this diagrid and this cantilever joint, I think you can go far.
Okay, thank you.
I also like to congratulate. It's amazing work and it's very comprehensive, and you attack all the problems. I just would like to make a few comments as a thought. One is this issue that's already been addressed of scale. There I think you should, I mean, what you do now basically is to measure the space or take the space of action of the robot and then scale your whatever it is, doesn't matter to this scale. I think it's reductive because what does it mean? Either to scale up the robot to the scale this doesn't work, or to scale down the architecture to the scale of the robot doesn't work either. So you will have to find strategy of further discretization. So you discretize the system first. And you said this was very clear that you need a system that allows to be stable or self-supporting while building. And if in the next step you think that you will build components, then also the assembly of these components, however it happens, will have to incorporate such a logic of being self-supporting. But this, I think, is a common issue we all have with these projects. That has to be. But what I think is very interesting, and where I'm not so sure if you're completely aware of what you do, is you propose this very intriguing tile somehow that is cantilevering and interlocks. And what it suggests to me, and you talk about low tech somehow, and I think this is clever because it's about simplifying things, not making them more complex, but then at the same time you say that they are all doubly curved, milled, 3 components, all singular.
Yeah.
And there you run into a conceptual conflict.
High-tech.
Not because of the high tech, because you have a machine that allows you to bring things at the right position in space, you know, so that can inform 3D space. And on the other side, you bring in so much information in this tile before that if I don't know that it doesn't work like this, but if I would just pretend, I could say, okay, if all those pieces really fit, I just assemble them by hand, because then I don't have this dimension issues and so on. Just put numbers on them and then I slide them in. And I don't know that it's not, because the advantage of the robot is that at every step it's again at the right position where it should be, so you can compensate for the bending and the tolerances.
Of course.
But I guess that with such a system you could go the other way. You could say, okay, let's make such a robust and simple building component, like a brick but more complex, that allows for degrees of freedom, you know,
And variation.
that makes maximum use of exactly what you manually cannot do, because if you have a tile and you have to place it somewhere, how do you want to know where, if you're at the right place or not? The robot knows automatically for free, you know.
The robot knows when you have like a sensor feedback into it,
No,
or the robot just in the simple position?
even without, you know, because if
Because it's
the
instructed.
joining of the components allows for example, deformation, because the robot also is strong, you know, could bring something,
Yes.
bend it through and then lock it, you know, or if this sliding connection, you know, has a, I don't know, 1, 2, 3 centimeter where it can be rotated, or then you can simplify dramatically the process and make full use of the machine capability, you know. And this is just as an input, you know. Probably it's not the solution, because I believe the solution. And one thing that I think is a pity that you did not incorporate in your sort of methodology is, or that you just ignored, is man-machine collaboration. Can it really be the goal that you exclude humans from this process? First of all, it's not realistic, you know. And in my mind, it's not even efficient, because there are, as you can identify things, the machine can be so much better and faster and more precise. There are many things the machine is, you said the machine is not intelligent. You spend a lot of time to give it some senses and so on, what is needed, but it will never reach your capabilities, even your layman capabilities, you know. Although you're talking about skilled labor, you know, understanding how. And if you propose a methodology that makes use of both, you know, skills, then you can solve all the problems automatically. Because if you run into the dead end, then you run into a problem where you say, okay, I can do it, the machine cannot do it, instead of trying to learn to the machine to enforce it. Because if you go this way, then you just do just automation, and this has already failed, because building, the big difference between car and buildings is scale, repetition versus difference. If you want it or not, even if you build, if you make a repetitive design, it's fake. Because if you look at the reality, and this is also because the reason why prefabrication or the industrialization of building 20th century has basically failed. You know, it's aesthetically repetitive, but if you look at the details, it's not. It's full of exceptions, because
We learned it on the hard way.
because there is context, and this can be analyzed throughout history. And the car is not this. The car is exactly the same. Otherwise, it's not possible. It's expensive and so on. You know. And the third thing, in car manufacturing, you have precision. you're not dealing with, you're dealing with very expensive material, you know. You use very little of them, but I mean, pressed sheet of metal is precise with, you know, 0.2 millimeter. In architecture, you forget about it. There you talk about, if you talk about centimeters, it's already great, depending on the context of the material.
Okay.
But thanks a lot.
Thank you.
Yes.
Thank you.
You have one more? Okay, please.
Io posso parlare un po' con Damaso e poi Damaso parla con loro?
Sì.
Sì.
So io traduco.
Sì.
Sì.
Una piccola idea da utilizzare, una colla, una specie di una colla
Sì.
che diventa solida tramite il calore.
Sì.
Comunque, dopo 1 o 2 minuti, il robot ferma così, prima mette la colla, ferma così, l'altra